आज का हमारा टॉपिक है, आज का लेक्चर का टॉपिक है स्पेसिफिक हीट और स्पेसिफिक हीट कैपेसिटी। स्पेसिफिक हीट और स्पेसिफिक हीट कैपेसिटी दोनों का मतलब एक ही है। तो इसको पहले हम डिफाइन करते हैं। व्हाट इज स्पेसिफिक हीट? इट इज द अमाउंट ऑफ हीट रिक्वायर्ड to raise the temperature of a substance of unit mass through unit rising temperature. Unit mass means 1 kg. If अगर SI यूनिट में बात करें तो unit mass means 1 kg. और through unit rising temperature means 1 Kelvin. Let C equal to specific heat, Q equal to amount of heat, and is the mass, and delta T is rising temperature. Then specific heat C can be equal to Q upon m into delta T. Q upon m into delta T. So by this formula we can calculate the specific heat C. And specific heat C, इसका SI यूनिट अगर निकालना चाहे SI यूनिट, तो इसका SI यूनिट क्या होगा? Q का SI यूनिट होता है वो जूल होता है, m का kg small k g and delta T means Kelvin. Then SI unit of this C is joule per kg Kelvin. So in case of solids and liquids, specific heat does not vary much. But gas के केस में क्या है? गैस के केस में we can have the value of specific heat from 0 to infinite. Depends on the process. किस प्रोसेस से हीट का एडिशन हो रहा है उस पर निर्भर करता है। तो सपोज C के केस में C for gas, its value can be 0 to infinite. 0 कब होगा? When you add the heat in a adiabatic process. Adiabatic process means when there is no heat interaction. When there is no heat interaction, then the value of C will be equal to 0 for adiabatic process. And C equal to infinite. When it can be infinite, when delta T becomes 0. And delta T becomes 0 कब होगा? जब प्रोसेस हमारा आइसोथर्मल होगा. Isothermal means when there is no change in temperature during the process. Means initial temperature is equal to the final temperature in case of isothermal process. So C equal to infinite for isothermal process. C equal to infinite for isothermal process. In this case, because Q equal to 0 in the case of adiabatic process, in this case delta T equal to 0 in the case of isothermal process. So C equal to 0 for adiabatic process and C equal to infinite for isothermal process. Because gas case में we can achieve different types of process. We can achieve adiabatic process means without heat interaction. We can increase or decrease the temperature. In case of isothermal process, we can add the heat without changing the temperature. So the value of C can be varies from 0 to infinite in the case of gases. But two specific heats are important in case of gas, that is your Cp and Cv. Cp and Cv is two important specific heat which are used for gases. Cp and Cv. Cp and Cv are what? Specific heat at constant pressure and constant volume. What is Cp and Cv for gases? Specific heat at constant pressure and specific heat at constant volume. I will explain Cv and Cp of gas. सबसे पहले Cv and Cp का हम डेफिनेशन देते हैं. It is amount of heat required to raise the temperature of a gas of unit mass through 1 Kelvin at constant volume and pressure respectively. Means unit mass means 1 kg. At constant volume means it becomes the definition of Cv, and at constant pressure means definition of Cp. Let U equal to specific internal energy small h equal to specific enthalpy. T equal to temperature. Then in differentiation form, Cv equal to du by dt, means differentiation of u with respect to t. Cv का डिफरेंशिएशन क्या होगा? Differentiation of u with respect to t. And Cp का डिफरेंशिएशन क्या होगा? dH upon dt, means differentiation of h with respect to t. You know that h equal to u plus Pv, and this can be equal to u plus RT, since जो Pv होता है it is equal to RT, गैस लॉ से Pv equal to RT. So if you now you got the equation h equal to u plus RT, if you differentiate it, it becomes dH upon dt equal to du upon dt plus R, because differentiation of t with respect to t becomes 1. In the next sentence, you can see just dH upon dt. It is what? dH upon dt, it is Cp. And du upon dt, it is what? It is Cv. And plus R. So from this you can get Cp minus Cv equal to R. And this is quite important relation. And for gases, not for gases, you can say for air. For air, Cp equal to 1005 joule per kg Kelvin, Cv equal to 718 joule per kg Kelvin, and R, Cp minus Cv. Cp minus Cv is equal to R, and R, the value of R is, if you differentiate it, it becomes 287 joule per kg Kelvin. So this is the concept of Cp and Cv for the gases. The first portion indicates the definition. Second is the value of Cv in differential form, du upon dt, Cp equal to dH upon dt in differential form. If you want to try this important derivation, Cp minus Cv equal to R, you can start from here, h equal to u plus Pv, and equal to u, and Pv equal to RT. It's the gas laws. Pv equal to RT. So the value of Pv, you can put RT by this equation, and if you differentiate h, so we got the equation h equal to u plus RT. If you differentiate it, it becomes dH upon dt, it becomes du upon dt, and R, because differentiation of t with respect to t becomes 1, तो वो cancel हो जाएगा यहाँ पे. तो dH equal to du upon dt plus R. dH upon dt is the Cp, and du upon dt is what? It is Cv, and plus R. So you got the formula Cp minus Cv equal to R. For air, because air is the working substance in many gases in practice also, so for air you should remember these values. Cp equal to 1005 joule per kg Kelvin, Cv equal to 708 joule per kg Kelvin, and Cp minus Cv is the R. R के value कितना होता है? R is what? R is the gas constant, and its value कितना होता है? 287 joule per kg Kelvin. So these are the important values, and you should remember these three values for the air.